A computer game, one of the most familiar pieces of electronics in just about every home. And inside the box is a very sophisticated device, one which is now being used to unlock stunning new ways to look at our world. Many computers and games consoles have a graphics processing unit, a GPU, to handle all the graphic calculations. These days, with 3D and fast frame rates, they have to be very powerful.
Yeah, so 5 years ago the GPU was very important to people playing computer games at home, but it wasn't of that much interest to scientists. But now, because of the developments with the GPU technology, it's really leapt out of the home computer and into the world of science, and it's set to have a major role in science going forward.
CSIRO computational scientists now have a new computer. It's packed with GPUs.
This is the CSIRO GPU cluster. It consists of more than 200 GPUs that contain about 40,000 computing cores. We also have about 1,000 CPU cores running on this computer cluster together. Combined, they mean that we have one of the fastest GPU clusters in Australia and one of the fastest in the world.
What makes it so powerful is that where supercomputers of the past were serial processors, this one is a parallel processor. To understand that, imagine you're out shopping. You've got a big list of items to get, and you wander the aisles picking them up one by one. You get everything you want, but it takes time, and that is serial processing. But if you get a group of people together and give them just a few items to find, you'll do your shopping in a fraction of the time, and that is parallel processing. In the CSIRO computer, the CPU splits a big task into small chunks and distributes those to the GPUs. They crunch the numbers and send the calculations back to the CPU, which combines the whole lot together for the final result. Up until now, even a short sequence like this of a dam break would take days to produce. Particles of water are tracked and their interactions calculated by the computer, frame by frame, until we have a complete rendering of a real-world event.
Those types of calculations require an enormous number of calculations in order to be able to perform that simulation. So we would run serial processors, potentially might be run for up to a week in order to perform that calculation. So in parallel, we'd hope to be able to do them much faster, 10 to 100 times faster at least. Every major industry now is using supercomputing or high-performance computing to gain a technological edge, to beat their competitors, and that's why we need to be at the forefront of supercomputing in Australia.
The GPU cluster will be available to all areas in CSIRO, from materials science to financial mathematics, chemistry, biology and physics. Later on, it will be offered as a resource outside the CSIRO.
Once upon a time, biology used to be limited by the amount of data that we could get, but these days the problem's been turned completely on its head. We're drowning in data, and the challenge is to do the analysis with all that data. So having a GPU cluster available gives us that extra horsepower that we need to tackle really significant bioscience problems.
We're currently working on a system for automatically grading opals called the Gemological Digital Analyzer, or GDA for short. Now the GDA captures hundreds of images to characterise the visual characteristics of an opal, and then we have to analyse those hundreds of images in a very short period of time. Doing that analysis using a standard computer can take about 20 minutes, and the throughput or the demand for getting these grades out is much quicker than that. So to be able to do this analysis, we need GPUs.
One of the fundamental operations we would use a GPU cluster for is aligning a tiny fragment of someone's genome back to a reference genome and doing that millions or billions of times over. So a lot of the time we're not working with graphics at all. It's just that these GPUs provide a cheap and cheerful speed up. It gives us a way in to tackle problems that we wouldn't have dreamt of tackling.
So for the pharmaceutical industry in screening cells, a pharmaceutical company will have a compound library of 1 million compounds. So when they're trying to find a new drug for a particular disease, they have to screen 1 million compounds. That means with replicates they will have probably 3 million images of cells. It's simply infeasible for a human to do this. It must be automated. And to get the screening time down from months and months to weeks, it demands GPU-enhanced computing.
The thing that most excites me about the GPU cluster are all the ideas that we haven't thought of yet. So by having this cluster around, I know there will be moments down the track when neuroscientists and other researchers will be saying, oh, maybe we could do this. And that kind of aha moment, that sort of like, let's try this, that's where the real excitement comes.
The CSIRO GPU cluster is now open for business.